Yeah, I want to welcome everyone on this platform for A-level mathematics by teacher Mwebaze. Ezekiel. Today we are going to explore the introduction of trigonometry right away. So trigonometry is a senior 5 and senior 6 topic that all of us we need to have in this new curriculum, and it's the basis of each and everything. Trigonometry has two parts. We have the first part of the word trigonometry, which is tri. Tri means 3. Then we have the next word on the word trigonometry, which is gono. And gono in Greek means angles. Angle. And then we have the last part called metry, which can be metria, which means measurements. It means measurements. So it means that the word trigonometry itself is a 3-angle measurements. So a 3-angle measurement is what we are calling trigonometry. Which means for us, the figure in mathematics that has 3 sides is a triangle. Therefore, the basis of trigonometry is going to be seen from a right-angled triangle. Now, from a right-angled triangle, it means that here the angle is 90, then the rest of the angles here are 45. If my adjacent is given A and the hypotenuse is C and B is my opposite, meaning to the angle theta, we shall have to look at the 3 ratios of trigonometry, and that is sine, cosine, and tangent. Now, from the diagram, we know very well that from the formula of O-level, we used to have it as so ka toa, where sine of the angle, if the angle is theta, for example, let this angle be theta, it will be the opposite of hypotenuse. And cos of the angle theta, it would be the adjacent of the hypotenuse. Then for tan, which is tangent of theta, will be equal to the opposite over adjacent. So, from SOCTOA, we know sine, opposite hypotenuse, cos theta, adjacent hypotenuse, and tan theta, opposite over the adjacent. Now, we want to develop the first trigonometric identity. If this angle here is theta, and I want to write A, the distance A, from here up to here, in terms of trigonometry, that is in terms of trig, and also the distance B in terms of what? Trigonometry. For A, distance will be equal to C, which is the hypotenuse, cos. Sorry, it will not be cos. Yeah, it will be cos, C cos of theta, and that's the distance A. We can write it in terms of trigonometry like that. Also for the distance B, it is the same as C, then sine of theta, this theta here, the angle. So that's how we can represent the distances A and B. Now, we know that from the Pythagoras theory, from the Pythagoras theory, theorem, a squared plus b squared must be equal to c squared. So, using this Pythagoras theorem, we have A in terms of B, in terms of trig, C in terms of trigonometry, B in terms of trigonometry, and A was C cos theta. But since here A is squared, C will be also squared, and cos will also be squared, plus B, and our B was C sine theta. But since B here on Pythagoras theory is squared, C will be squared, and sine will also be squared, and this is equal to the hypotenuse, the length side, which is C, but is squared. In this equation, we see a common factor, which is C. So I'm going to divide all through by C squared. So when I divide by C squared, I remain here with cos squared, here with sine squared, here with 1. So here we'll have cos squared theta plus sine squared theta, which is equal to 1. Which is equal to 1. So that one is our first identity that we have for trigonometry in senior 5. So whenever you see cos squared plus sine squared, it must give you 1. So we are going to derive other trigonometric ratios or formulas or identities. In fact, we call them identities using this first trigonometric identity, cos squared theta plus sine squared theta. Let's go. So from cos squared theta plus sine squared theta equals to 1, we can make cos squared the subject. So cos squared theta the subject is the same as 1 minus sine squared theta. That's when we take sine on the other right hand side, which becomes a negative, and that will be another identity. In this way, you can represent cos squared theta with 1 minus sine squared theta. Then, that is one way. We can also make sine squared theta the subject, meaning that cos will cross the equal sign and it becomes a minus cos squared theta. So this one is also an identity in trigonometry that learners must understand. So you can represent sine squared theta with 1 minus cos squared theta. Now, still from the very first trigonometry, cos squared theta plus sine squared theta equals to 1, we are going to divide that equation all through by cos squared theta. But before we do this, to get other identities, we must know that tan theta is the same as sine theta over cos theta. And then we have also the ratio called cot of theta, which is the same as cos theta over sine theta. We also have 1 over cos theta, which is the same as sec theta. So a student must know these other trigonometric identity, that tan theta is the same as sin theta over cos theta, and then cot theta is the same as cos theta over sin theta. Then 1 over cos theta is the same as sec theta. We also have we also have 1 over sin theta, which is the same as cosec theta. Now, all these ratios seems to be new to some of us, especially those from senior 4, but we need to be familiar with them. We are used of tan theta being cosine theta over cos theta, but you need to be also understanding other trig identity, like 1 over sine. As I said, it is the same as cosec theta. Now, cosec theta in full is called cosecant of theta. Then 1 over cos theta, we said it is the same as sec theta, which is the same or in full it is secant of theta. So these ones seems to be new ratios for trigonometry, apart from those that you studied in O level. Not also forgetting um, cot theta, which is the same as cos theta over sine theta. In fact, this one is the opposite of tangent, because tangent, which is tan theta, is the same as sine theta over cos theta. But we are seeing that cot theta here, it is cos over sine. So that's the difference. Those are the new ratios that you need to know. Let's go back and derive the formulas. So we want to derive the formula from our mother identity, or the first identity, cos squared theta plus sine squared theta, which is equal to 1. And I said we want to divide by cos squared theta. So dividing by cos squared theta throughout, we shall have cos squared theta over cos squared theta plus sine squared theta over cos squared theta, which is 1 over cos squared theta. Cos squared theta. Now, remember we said cos squared over cos squared, mathematically it gives us 1. Our operation is plus. Sine squared over cos squared, we said that sine theta over cos theta gives us tan theta. But now, since here the sine is squared and the cos is squared, it implies that even this tan is going to be squared. So here is going to be plus tan squared theta. Then remember we say that 1 over cos squared theta is the same as sec. The other time it was 1 over cos when it's not squared. It means that here it's going to be sec squared theta. So 1 over cos squared is the same as sec squared theta. And on our equation, it is the last part on the right hand side, which is 1 over cos squared, which is the same as sec squared theta. So this is an identity. 1 plus tan squared theta equals to sec squared theta. So this identity is very important. The importance of this identity is that 1 can substitute or represent 1 plus tan squared theta with sec squared theta. Or 1 can substitute sec squared theta as 1 plus tan squared theta, especially when we shall be dealing with solving of trigonometric equations, and also when we shall be dealing with proofs of the trigonometric identity. So note that identity is very, very important. But still, from this very identity, we can have tan squared theta alone to be equal to sec squared theta. Then this 1 crosses the other side and becomes minus 1. So this one is also an identity, that tan squared theta is equal to sec squared theta minus 1. Very, very important to note. Now, all these two identities here and this one, we have got them by dividing our first trigonometric identity by cos. Right now, we want to go back and we'd leave or obtain some identity when we divide the first trigonometric identity by sine squared theta, and we see the results. Now, from the same cos squared theta plus sine squared theta equals to 1, we want to divide this equation by sine squared theta. Recall that cos theta over sine theta is the same as cot theta. Don't forget that. And also recall that 1 over sine theta is the same as cosec theta from the beginning of the topic. So, we shall divide by sine squared theta throughout this first identity. So we shall have cos squared theta over sine squared theta over sine squared theta plus sine squared theta over still sine squared theta, which is equal to 1 over sine squared theta. Now, sine squared theta and sine squared theta is going to give us 1. But cos squared over sine squared, we say that cos theta over sine theta equals to cot. But since these ones are squared, we shall have cot but squared. So this will be cot squared theta. Now, equals 2, we say that 1 over sine theta is the same as cosec theta. But now, our sine here is squared. So that means that we shall have cosec squared theta. Shall have cosec squared theta. Now, this is cosec squared theta. So that one will be another new identity. But we want to get more identity from it. This is equal to cosec squared theta. More identity from this identity that we have formed by dividing signs throughout the first identity, we can make also cot squared the subject, meaning we take one the other side and we shall have cosec squared theta minus 1. This one is also a very important identity. That is very, very important. So we have got cot squared plus 1 equals to cosec squared theta, but still we can make cot squared the subject, and we have cosec squared theta minus 1. So those formulas and those identities are very, very important. But still someone might need cot theta alone. So if you need cot theta alone from this, we can square both sides and we shall have it as cot equals to cosec squared theta minus 1. So this identity is also important, especially when we shall be dealing with some kind of proofs. So we have got at least the introduction to trigonometry, and we have also known how to obtain the identities. We have still known the new identities like a cot, which is cotangent. We have also looked at cosecant. We have also looked at secant. Then we have been used to sine, cosine, and tangent. So we now have 1, 2, 3, 4, 5, and 6 trigonometric ratios that we need to work